This is a fiberglass composite wing segment for a fixed-wing UAV like this one. To tell you all about it, I had an interview with John from Selby Piper. We'll go through a lot of cool stuff, like the process of making a composite part, what makes it the gold standard for lightweight performance, why they chose to develop drones using composites instead of 3D printing, is it viable to scale composite manufacturing, and how we can develop a mold at a lower cost for startups. We'll do cost estimations so that we can get a rough understanding, and we'll discuss why they prefer to work with fiberglass instead of carbon fiber when it comes to fixed-wing UAVs, because there are some issues with radio and GPS interference. My name is George, you're watching the Pathfinder Series. Enjoy the interview. All right. Hi John, it's good to see you. So John is the CEO of Selby Piper, and they are an experienced drone manufacturer using composite technology. So John, can you share about what you do at Selby Piper?
Selby Piper is mainly a research and development, in the majority focused on wing and ground effect craft. But we sort of branched out into drones just because we did a project for the MOD with a wing and ground effect craft, and they were quite keen on a drone wing and ground effect craft. But when it comes to manufacturing, I've got a sister company called Custom Carbon Limited, which has been going for about 20 years. We do the R&D in Selby Piper, and then we do the manufacturing in Custom Carbon, basically.
Okay.
So it's really a R&D company rather than a manufacturing one at the moment.
Can you share a bit about the process of how you make composite parts for drones specifically?
We mainly focus on a pre-preg system, so that we get our carbon fiber, fiberglass with the resin already pre-impregnated into it. Mm-hmm. So it comes on a roll, we store it in a freezer so it doesn't go off. And when we come to use it, we, put it on a table, cut out our template with a Stanley knife, layer it into a mold, then vacuum that down and cure that over perhaps 15 hours at 85 degrees.
85, okay.
There's obviously a whole range of different ways to process, but that's what we sort of focus on the most. But sometimes we have to do a wet lay system, or we have to do a resin infusion system. But in the main, we focus on the pre-preg because the system comes with the exact amount of resin you need for the fiber. Okay. So if you're going to wet lay, you'll maybe put in more resin than's required, and the product will be heavier than it needs to be, really.
Okay, that makes sense. So are you 3D printing the molds?
Sometimes, but we've had quite a bit of trouble in the past. The quickest way was just literally to 3D print a pattern. Mm-hmm. And then I made a mold from that pattern. Ordinarily, if you've got a production system, you would need to get some tooling board. That would be CNC'd. Mm-hmm. Then you would make your molds from that tooling board, and then you could make the parts from those molds, basically.
And that CNC mold, I guess that's something rather expensive. So it makes sense.
The CNC patterns can be incredibly expensive.
Yeah.
So,
okay.
If you're going to get a really, really good deal on, say, something like the Stallion, mm-hmm. that size, you're probably looking in the region a minimum of sort of £20,000.
Okay.
Just for the patterns. You've then got to make the molds from those patterns.
And then
basically
the vacuum equipment and the oven isn't that expensive, I guess?
No, not really.
Not
really. I mean, we've got a pretty decent oven that we don't use that often. It's a sort of high temperature one. Mm-hmm. But otherwise, our ones are made out of a Kingspan material. And we've had them. I've had literally one oven for 20 years, and it's very good. It must have cost in materials, £400.
I also hear in the community that some of the hobbyists, they are printing with something like lightweight PLA, and then they apply a single sheet of fiberglass and epoxy. I'm not sure if they even vacuum it, because that would be very hard. Is that something viable if you're looking for something more accessible?
I would say so, yeah.
Yeah, okay.
Yeah, I would say that's a pretty decent route to go. The 3D printing for prototypes is just absolutely amazing. If you want to show something visually or even test it to some degree, because, it's not your final product. You're cutting out a lot of time, a lot of expense, especially if you're going to perhaps tweak something, change something. That's very expensive. It's really helped us a huge amount. We're a bit late to cotton onto it, but we did eventually.
Yeah, so this is one of your parts. Thank you for sending it to me.
No problem.
You also sent a wing segment. My question is, what will be the infill here?
We just have literally a Z bracket, which goes along the length of the aileron.
Okay.
So that's a separate piece.
So inside it's just hollow, no infill.
I'm not sure about that one, because we've sort of cut that one a little bit shorter. But there's two ribs and there is a Z bracket. In fact, that's if you've got literally 30 seconds, I've got one in downstairs. I can actually show you the aileron part.
Okay.
And it'll make a bit more sense to you, actually.
Yeah, okay.
So that would be your upper skin.
Okay.
With the built-in upper of the aileron.
Okay.
And then what happens is you have a lower piece of the aileron, which gets bonded onto there.
Okay.
And the lower skin has a Z bracket, which sort of closes out. In fact, it's the wrong.
Yeah. Okay.
The wrong one for the.
I understand the idea. My question was more related to the infill between the two fiberglass parts. Do you fill it with foam or something? I'm not asking about structural spars. Just what is there an infill? Okay. Yeah.
There will be one rib here.
Mm-hmm.
And one rib there.
Mm-hmm.
And that's all you need.
And they are connected.
That's all you need. Once it's sort of bonded together, it's super strong.
Okay, that's interesting. So you do not need an infill.
No.
Like the 3D printed wings need, right?
All right. We actually did experiment with a whole load of different foams as an infill.
And you ended up not needing foam?
It was just too heavy.
Too heavy.
It was just too heavy.
Okay, yeah.
Because we experimented basically with the rear wing setup. And it's unnecessary. The sort of wing skins themselves, when they're bonded together, they make a pretty decent product.
Okay, yeah, that makes sense. Because for 3D printing, of course, you do need infill. And for example, here I'm using just 3%, but this is so rigid, like you wouldn't be able to bend it.
Yeah.
So that's an interesting difference. I guess if I were to ask you why composites are the gold standard in the aerospace industry, it would be the strength to weight ratio.
Absolutely.
Yeah. And what is the process after the fiberglass part is ready? What do you do in terms of post-processing? Do you sand the part? Do you paint over it? How does that work?
Right, because we've gone for a pre-preg system, the surface is actually a pre-preg. It's like a pre-preg gel coat.
Okay.
Yeah. But that is almost impossible to paint.
Okay.
Because if you look at the surface, there are minuscule pinholes.
Yeah, I can see them.
Yeah, you can see it, not from a distance, but once you start sort of looking close up, and when you start trying to paint that, you could spend more time preparing it in order to paint it than it did actually to make it. You know, a lot more time.
Right.
So what we do is we just wrap it.
Ah, okay.
I've got a friend who's got a wrapping company, basically. So
Okay.
I'm not sure what the sort of technical name of the wrap is. It's an extra weight of about 200 grams per square meter, which is quite a bit. But then, you know, once you start sort of using a different gel coat instead of that pre-preg gel coat, you know, a paint on or a spray on gel coat is quite heavy. And then once you start painting on top of that, it all adds up. So the only sort of drawback about the wrap is that, you know, sometimes you can catch it and it will start to, you know, have some imperfections in the surface, but it's, you know, you can replace it. The benefits are that a customer can have a custom wrap. They can have their logos, they can have any color, you know.
Yeah. And I suppose it provides UV protection as well. Which
very much so, yeah.
Yeah.
Yeah. But the problem with a gel coat and a pre-preg system is it's very difficult, you know, to use a gel coat when you're using pre-preg system. You can use it for a wet lay system, you can use it for a resin infusion system, but when it comes to using pre-preg and gel coats, it's very difficult. It doesn't work most of the time.
And that makes me wonder, would it be viable, in your opinion, to use gel coat on a 3D printed part?
I wouldn't apply a gel coat myself. I would probably just go with an epoxy paint.
Okay.
An epoxy primer, maybe. Because epoxy sticks to almost anything.
Right.
But a gel coat would you'd just be creating a lot of work for yourself. You want to get a nice finish, so you want a really sort of fine spray. Gel coat is quite difficult to spray.
Okay. As you know, 3D printing unlocks a lot of the opportunity to print very advanced shapes, which may have a benefit in terms of aerodynamics, because you can print all sorts of intricate tunnels inside the wings and so on. Do you believe that composites are a limiting factor when it comes to design freedom? And is that something important? Because I see most of the aircraft, they have pretty basic shapes, and that works. So would 3D printing have any advantage when it gives you such design freedom? What's your opinion?
Absolutely, in some cases. You know, if the whole thing about a composite part is you have to take it out the mold without any adverse angles.
Yeah.
So if there's an adverse angle, you're not going to get it out the mold. And if you've got small, complex parts, for example, your mold has to be in different sections, all bolted together, basically. It's a minefield. It can be very, very complicated. And then, you know, how do you actually get your pressure into the part to press it against the mold in order to cure it? So certainly, I mean, you know, there is no competition with some sort of 3D printing, you know, potential.
Okay. I love also the idea that you're applying additional cloths as reinforcements, additional layers, and this makes the part quite rigid. Yeah. So the next question is, why did you choose fiberglass over carbon fiber? I've heard that there are some issues with radio interference. Is that the reason?
One of our first clients stipulated that he wanted a full fiberglass system. Mm-hmm. So we went down that road and we worked with the actual supplier of the materials, company called SHD Composites. They provide the pre-preg materials. Mm-hmm. So they came up with a system. They, for example, put the pigment into the system. And basically we did, a drone that we were very, very satisfied with. And we just basically continued with the fiberglass because it was working for us.
Okay.
So for example, that part that you've got there, mm-hmm. that is made with a surface material, which I think it weighs a little bit under sort of 200 grams per square meter.
Wow.
Then we have the fiberglass layer, which the material itself, the fiberglass material itself, weighs 50 grams per square meter.
Yeah.
But then we have a resin material, mm-hmm. which we put on so that the foam core doesn't take all the resin out of the fiberglass material. And then we have one more layer of fiberglass, which the fiberglass alone, again, is sort of 50 grams per square meter. So it's almost like working with sticky silk. The fibers, the fabrics are that thin. So that's how that system is. The fuselage, instead of the 50 grams per square meter, we use 100 grams per square meter. We just need a little bit more impact strength on the fuselage. Okay. It's really trying to get, push the boundaries, basically, see what we can get away with.
Yeah, and if you were to use...
And basically
Yeah, sorry.
The customer had stipulated fiberglass purely because of the interference that the carbon has with the signals, basically.
Okay, yeah.
And we found that anyway with our other projects where we've had to literally cut out areas of the wing and ground effect craft and replace it with Kevlar because the GPS wasn't was being blocked basically.
Right. Yeah. And even if you make the wings carbon fiber and the fuselage, I guess there is always some point where the signal could interfere. So fiberglass is the better option.
It was. Yeah, we just wanted to remain consistent, mm-hmm. and to we actually haven't explored carbon fiber as much as we could have really. So it's just the road we went down. It was working, so we kept it.
Okay. And for someone like me who is a beginner in this field, an enthusiast, and is perhaps making a startup, how can we estimate the cost? So we know that if you want to 3D print a section of a UAV wing, it's relatively inexpensive because you can use desktop 3D printers, which are so good nowadays. And the filaments, even if you use the most advanced filaments, they're still relatively inexpensive. How do we begin to calculate the cost difference between using composite? If you were doing very low scale production, like 1, 2, 5, or 10 drones a year, that's max. Would composite even make sense?
Your main cost is actually creating your patterns, okay, and then making the molds from those patterns or forms, as some people might call it, and then being able to make the part from the molds.
Okay.
So that is a huge expense. So, you know, it just depending on how experienced people are, they could potentially, as you say, create a mold from 3D print.
Okay.
And they could then wet lay into that mold. You can't really vacuum most 3D prints because it will collapse.
Yeah, that makes sense.
It will collapse. So when you were asking the question, can you put some material over a wing and then vacuum it? Probably not. Mm-hmm. Probably not. You know, you're going to have to use maybe 1 bar of pressure, sort of 1, atmospheric pressure, and that is very, very likely just to collapse the whole structure.
Okay. But is it because there are air gaps when you 3D print, or because you think the 3D printed structure wouldn't hold the forces?
I don't think that the structure would hold the forces. Basically,
that would be an interesting experiment, because with the newer, stiffer filaments and nylons, and if you do enough infill, I'm pretty sure it can hold substantial weight. But that's something worth trying.
I tell you what I could try is I've got a wing, a few wings of the Stallion, because we had to go with that, and I could certainly put that in a vacuum bag and vacuum it down and see how that performs, if you like.
No, I meant not the wing segments, but the mold itself. If you were to 3D print the mold that you lay the fiberglass pre-preg onto, and then if you were to vacuum that, I guess that would work.
Yeah, feasibly.
Feasibly, okay.
Feasibly, yeah.
So if someone is
probably probably not be able to take it to a temperature. So you couldn't use a pre-preg system, but you could feasibly use a resin infusion system.
Okay.
So you would take your fabric and you would lay it in the mold, and then you would put that in a bag, and you would basically suck resin through the whole system.
Okay.
And then you've got a really good sort of weight ratio, sort of fiber to resin. So that's also, and you could also just wet lay. You could just put your fabric into the mold and wet lay it, and then sort of vacuum that down as well.
Okay, so for the pre-preg method, we do need to heat up the filament, the part, but that's after vacuuming it, right?
While it's vacuumed down.
While it's vacuumed, you need to heat it.
Yeah, so
okay.
We'll put it in the oven for 85 degrees for...
Yeah, you said 85 degrees, but like modern nylon filaments, they do not start deforming up to over 100 Celsius. So theoretically, that might work. Theoretically, yeah. But that's super interesting because, again, from the perspective of someone who is doing very low volume or is just starting out, because we anticipate an explosion of drone startups, right?
Absolutely.
Absolutely. Yeah. So, what is the best way for them to start? That's the big question I'm trying to answer here. And I guess it's a hybrid approach of using both 3D printing and composites. And one of the ways is either 3D printing the molds using advanced filaments, or you can 3D print the aircraft with advanced filaments and then apply fiberglass on top of it.
Or you can 3D print the pattern, the form. The form, okay. Then make a composite mold from that form.
Okay.
And then you have a composite mold that you can make multiples of parts from that mold. And then you don't need to worry about temperatures and you can make the mold without off that 3D printed pattern without taking it to temperature. You can let it cure at room temperature, and then you can post-cure that so that it's ready to. So that might be a better solution. It's just it's another step, but it's also viable. So you're cutting out a huge cost of getting somebody to CNC from tooling board.
And that mold that we would do from composite, how long would that last? Like maybe we can do 10 aircraft and then it would degrade, or it's...
Depending on depending on how well the mold is made, how well you look after it, clean it, release it, 50, 100.
Okay, yeah. So that's very viable for a startup.
It's definitely, it's certainly a way that I would approach it.
Yeah, and I guess with a CNC mold, you can reuse it infinitely. You can do larger scale manufacturing.
Absolutely. Well, we make the molds from a pre-preg system. So there's so many different ways to make the molds, and the cheaper it is, the more problems you can get in the future.
Right.
But going back to using the 3D print as a form or a pattern to make the mold, you could spray on an epoxy primer, for example, and that would give you a lovely finish. And you would then sort of release it and wax it, release it, whichever system you're going to use.
Okay, yeah, that does make a lot of sense. So we actually found a viable solution for startups. Yeah.
It's as a beginner with the composite side of things, if you are just an absolute true beginner, you're going to make a few hiccups here and there. But basically my analogy is, if you can paint a wall, you can do composites.
Okay,
it's quite simple. It's quite simple. Yeah.
Okay, so maybe now that we touched on the startup cost of doing this, what would be the actual cost of materials? Because this drone that you see behind me, this is using less than 500 grams of filament, which would cost, I guess, about like 50 or 60 euro total material cost.
Yeah.
Of course, this is far from the performance and rigidity of this. But what would be the material cost for both the fiberglass cloth and the epoxy? Just very rough estimate for the whole aircraft that you're building.
Okay, so your cloth comes with the epoxy pre-impregnated into it. So I would say, sort of, depending on the volumes you're buying, your surface material is probably about 38 pounds per square meter.
Okay.
I would say your fiberglass material with obviously the impregnated with the epoxy is probably about 35 pounds per square meter. So you've got two of those. So that's 70. So that's 108. And then you have a resin layer. So that's like it's like a resin on a scrim. So it's incredibly lightweight cloth, which just basically holds a layer of resin. Okay. And you need that resin because the foam core will suck the resin out of the rest of the system. Even though it's a sort of closed cell foam, it will take some resin out of the system, and that can sort of compromise things. So where are we? 108, and then I think we're probably looking at 20 quid for the resin film. and then per meter of the foam, I think that was about 22 quid or something like that per meter. So what are we looking at? 22.
Okay, so
looks like bang on 150 quid.
Per square meter.
Just an estimate per square meter.
Okay.
And then I forget exactly what that the drone that we're sort of focusing on now. I think that's probably 1.5 meters square. So you're looking at sort of 225 pounds for the layup. You then have all your consumables. So you'll have a bag that it goes into. You'll have an air bleed system, which is just like a thick. It's called an air bleed, and it basically allows for the air in the bag to get to the valve easily. Mm-hmm. And then you have a tacky tape system, which is used to seal the bag. Probably, let's say another 50 pounds, or probably less actually, probably about sort of 25 pounds. Sometimes you're reusing a lot of that.
What was the wingspan of your aircraft?
1.72 is this one.
1.72 meters wingspan. Okay, so that's surprisingly reasonable. I was expecting it to be a lot more.
But the weight itself,
I
think was, for all the composite parts, before we started bonding them, that's not including the carbon rod, I think it was 1.3 kilograms.
Okay.
For the whole, which is quite good.
Yeah, indeed.
So you're probably adding to that 1.3 kilograms another 5% for glue in weight.
Yeah.
I forget what the carbon
rods
were.
But then you use the same carbon rods with 3D printing, so yeah.
Absolutely. Yeah. I think we got to, for that one, without sort of the motors, et cetera, I think we were looking at about 2 kilograms all in, and then another 200 grams for the ramp.
Another 200 grams. Okay.
Yeah,
right.
so 10%.
That's very reasonable. I would be very interested in seeing one of your full-scale aircraft, so maybe we can organize that next. But other than that, John, thank you so much for your time. All of the things that you shared will be super valuable for anyone watching. And we actually found a viable solution for startups to begin doing composites, which is amazing. Yeah. So thank you again so much.
Thanks for having me, George. I've really enjoyed it.
Massive thanks to John for taking the time to do this interview. I hope you found it valuable. Please consider liking and subscribing so that John's insights can reach a lot more like-minded enthusiasts like ourselves. Thank you for your time, and I'll see you in the next one.